The last part of our exercise is about typecasting. What is typecasting? Typecasting is converting of variable of one type to a variable of another type. So let's imagine that you have already written your Java program and you have some variable like zip code, and this variable is of type byte for some country. Then during the deployment you see that actually the byte that can have positive values only up to 127 is not enough for your variable zip code, and you want to change the data type of this variable to integer. The process of converting of a variable from one type, in this case type, byte, to another type, in this case it would be integer, is called typecasting, or in this case this is widening conversion. So there are two types of conversion, widening and narrowing. You see now on your on this slide from the lecture that widening conversion is when you want to increase the memory size that was allocated to your variable, and that is that you are going here from byte to short, or from byte to integer, from byte to long, and so on. So you're increasing the size of the memory that was allocated to your variable. That is, you are changing the data type to a direction, to a bigger direction. You can use this also as implicit casting. That means that you're not specifying explicitly that you are making typecasting, so this will be done by Java automatically. So let's come to some example. Let us create a class with the name typecasting with main method inside. First, what we want to do, we want to declare and initialize in one line, just to save some time, two variables that we would play with. So initialize. First variable will be of type integer. This is variable int a. And let us say that this variable has value 4. Another variable is the variable of type float. And the name of this variable is float b. And the value that we assign this variable is 6.82. And don't forget, put f at the end. So the first option, we want to widen, we want to use widening conversion. So let us say that we want to convert our integer variable int a into double data type. So we can first declare the double variable that's name is double x. So we could declare on one line and then initialize on another line. We will just do it here on the same line. And now first option, we are using implicit casting. That is, we are just putting here the name of the variable that we want to apply widening conversion to. So this is implicit casting. let us print some results to our console to see what do we receive. So what we want to print? We want to print first the value of initial variable integer a. Let me close maybe this part here. And here we are putting int a, and we want to have also a dot at the end of the sentence in this way. So when we print, let me put it here in this way. Yeah, now it's better. So we see that here the value of integer a is 4. So this is exactly what we had here at the beginning. Now we want to see what do we have, what kind of result we have after our widening conversion, after we converted the integer a variable from int data type to double data type. So we will use system out print line for this purpose, and the value of double x is double x plus dot, and don't forget semicolon at the right place. Doing run with Ctrl F11 shortcut, and we see now that our double x variable that actually has the same value as integer a variable that initially was integer has now one decimal point at the end. So this is now it is 4.0, and indeed this variable can now have the values of that are much higher than the value that could be in integer variable, because the memory size that we have allocated to double is higher than it was in integer variable. This was the widening conversion, and this was implicit casting. However, it is very advisable to use explicit casting, and that is when you actually will just copy this statement. When you do the same, but you're specifying explicitly that you want to convert this integer a into data type int a into data type of double. So you're putting the type of this new variable in of conversion type in brackets, and you're assigning this value to double x variable. So I have here error because we cannot do twice the same, so I will just comment out the first line. And this is explicit casting. The second option is narrowing conversion, as you see on the lecture slide. Narrowing conversion is when you are converting from a data type from a data type that had bigger memory size allocated to some with smaller memory allocated data type. So let us see how it looks in an example. So narrowing conversion, and in our case we want now let us say convert this the variable float b of data type float to integer. So in this case, if we would use now the same method of implicit casting here as we did it for widening conversion, float, let us name this variable int y, as now float b Okay, here it should be integer, sorry. Exactly. We receive automatically here some note from Eclipse, and it tells us narrowing conversion. That was actually our commented line. And you see the suggestion. It suggests you to explicit tell Java to which data type you want to convert it. So when you are doing narrowing conversion, you have to specify explicitly the data type you want to convert to. So float b, you want to convert this variable to a variable of integer data type, and you're assigning this value to a new variable int y of type integer. So we want now to see what kind of results we receive as the result of this operation. So first we will print out the value of our variable float b, float b plus dot, and you see here this is original value 6.82. So then we applied our narrowing conversion, and now we want to see the value that is now saved inside of our new variable int y, and this is only 6 because integer doesn't have decimal points. So as a result of this narrowing conversion, this value has just lost the decimal points, and you see that as a result of narrowing conversion we do have information loss, and as a result of widening conversion there is no information loss. Just to describe maybe in a bit more detailed and maybe better way for you to understand how it looks like and why, let us have a look on these slides. This slide is already known to you. These are our variables, and you see here, just for you to remember which memory, how much memory is allocated to all those variables. And here is a summarization for narrowing and widening conversion in both directions. So let us come back to our artificial example when we had some memory of size just 64 bit, and this is all that we have, let us say. So let us say that you have now a variable of type byte, and this variable of type byte has 8-bit memory that is allocated to this variable. So let us say that you want to convert this variable to the type short. So initially your variable had this part, this cell of the size 8-bit. When you are converting from byte to short, then you are allocating twice as much memory. So you are enlarging it. And of course, you don't have any information loss because you're allocating just more memory to the same variable. When you, for example, like just similar example, if you have integer variable, and this integer variable has, here is it, 32 bit. So this is our integer variable here, and you want to convert this integer variable to a long variable. So you will now assign the whole memory to this long variable, but still it is the same variable, just with more memory allocated to it. This is the widening conversion. When we have the narrowing conversion, and let us just take the same example with 64-bit memory size, and we divided it into 8-bit. So let us say that you want to convert from integer, and our integer is here, is allocated here. So actually you have now, you could allocate here two integers. You want to convert the integer into a byte. It means that you would now just take out this part of memory, we'll just throw it away, and only a part of it, of the size of 80 byte, will be left to this new variable as the result of narrowing conversion. So now we will come back to our Eclipse, and let's have a look on another example with type casting. For this purpose, I will just create a new class with our main method, and the class is called another type casting example. So let us say that you have a variable float x, and you want to assign this variable the result of operation 3/4. How do you think what will be the result of this operation? So we can just tell this as the result to yourself, and now you will check yourself whether your answer was right. So we are printing now system.out.println the result of this operation to our console. The value of x is x plus dot, and the result is 0, 0.0. So why does it happen? Why did it happen? The thing is that when you are doing this operation, it is by Java, it is done in several steps. So first, the operation is done before the assignment. The operation here means that the number 3, and as default, Java assigns number 3 to an integer data type. It will be divided by integer 4, and the result of integer division 3/4 is 0. And the 0 result will be then implicitly converted to float data type. So from integer 0, it will be converted to float 0.0. What you could do, like what you should do if you would like to receive actually the floating point division, then you would need to write explicitly from the beginning. Float y, let us say y, equals to, and now you're writing explicitly, float 3 over float 4. And we want to print the result to console. And you see now 0.75. You could also write in a next option, in the next way, as float y2 equals to float 3 over 4. So let us have a look on the result of this operation. This is y2, and here we put also y2. I didn't put here the brackets. So now it should be. So now we have again 0.75. Why? The thing is that now Java sees that here we have number free variable of type float that will be divided by 4. So Java assumes that 4 is integer variable, but then in order to make the division, Java needs two same data types. So it does automatically implicit casting from integer 4 to float 4. And then the result of float point division, float 3 over float 4, is assigned to variable y2. And the last option is, actually it's, maybe we'll just put it under this line. This is float x2 is when you write 3, well, actually not, let's take it out here. Let us say this is float z, that is 3f over 4f. And we want to print it out. And you see 0.75. Because you are not using here any conversion, because these variables, they are from the beginning float pointing variables. Here, if you don't have any letters after the numbers, it's integer for Java. If you have f, it's automatically float. If you have l, then it is automatically long. Concerning L, it is advisable to write it always big. I will just show you here example. Long z1 equals to 3L over 4L. So you could write it in small 3L and small l lowercase. However, in this way, you could mistakenly think that this is not L, this is 1. That's why usually you should write L big one if you need it, if you do it. Okay, so this is all for type casting here. So before we come to our homework, I just wanted to tell you some words about literals. So if you open the primitive data types and literals file that you will find in Moodle, you will see here at the end some examples of using literals. So literals, these are usually these are numbers that are presented in a code. So literal is this one, this is literal, this is literal, this. So all the numbers and values that are assigned to variables. You can also use escape characters that have some special meaning, and you want and if you want to display text in some specific way. So the example you will find here. So these are just several examples. Of course, there are many more. If you want to have some specific character displayed for you that usually is used for code, then usually you put a backslash and then you put this character. What I wanted to tell you about is underscore character, and this is the character that you can use for better readability almost everywhere within literal. So for example, let us have a look on this long variable. Actually, this is just from the first look, it's pretty difficult to understand, to read, like how many zeros are here, or how high this value is. So in this case, you can use underscore that you are putting just like usually for numbers after 3, but it depends on you where you want to put it. And now you can better read this number. So you can put this at the underscore almost everywhere, because there are some exceptions, and these exceptions are pretty easy to remember. You cannot put underscore at the beginning and at the end of literal. So for example, here you cannot put it. You see immediately there is the error pop-ups, and at the end you also cannot put it. This is the first rule, and the second rule, you cannot put it right before or after decimal point. So here we have, for example, decimal point. We cannot put it here or here. You see the arrow pops up. And yeah, that's all. So our homework. Oh, your homework, actually, the homework that was prepared for you. The homework for exercise number 1 contains 3 parts. So the first part is that I advise you to open all the codes that you will find in Moodle and to play with them. So it means that you are just playing code, and you are trying to change any values. You are trying to print another statements to the console. So it's just for you to receive a feeling of this programming language and to get used a bit to it. So this is the first part. The second part is are quizzes. The quizzes you will also find in Moodle. The quizzes are the questions with multiple choice questions. You can go through all those quizzes and use them as some kind of check for yourself to understand how good did you got this topic. The quizzes will prepare you to our exam, because we will have similar questions at the first part of the exam. You can have a look on the example exam in the Moodle from 2016. So you'll find pretty similar questions there. The second, you'll find there also some questions from preparation to OCP, Oracle Certification Program exam. So this will also prepare you to some extent to the exam, if you would like to take it. So first goal of the quizzes for you to check your knowledge and to prepare yourself better. The second goal that I have for those quizzes, and actually I will do this maybe starting from the next exercise. I will put some questions that not were explained fully during lecture or during exercise, just since we do not have so much time. I already see that it already takes maybe too much for the first exercise, but well, it's just 2 weeks, but still a bit too much time. Feel free to feed forward on YouTube. So you know that every programming language has a very big part of self-study. In order to master any programming language, you need to take your time and just to code. There are concepts, of course, there are a lot of concepts that will not be covered by our lecture and exercise, but that are also important. So there will not be too much of those unknown tasks, but please don't be frightened if you will see something like this. The same is advisable for you when you are going through the code that I'm explaining or that is explained in the lecture. If you don't understand something, then just search for this for your better understanding. The last part of the homework are the programming tasks. I think there are only 3 of them for this exercise. Yeah, so the solutions, I will make them available just immediately in the Moodle, because these quizzes and programming tasks, they are for you to prepare better to exam. So just it's up to you whether you will first do quizzes and programming tasks, and then you will just check yourself using those solutions. So thank you for your attention. And if you have any questions, please write in Moodle, and see you next time.